Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing motion graphs. We shall be dealing with basic questions, and we shall start with VT graphs. VT means speed time. So V stands for speed and T stands for time. So for the following set of problems, we will be dealing with speed time graphs. Each cheetah runs for 60 seconds. The diagram shows the speed time graph. Work out the acceleration of the cheetah during the first 10 seconds. So you should know something about speed time graphs. We have three quantities that we're interested in, A, V, and X. And to go from A to V, you need to get the area. To go from V to X, you need to get the area as well. But to go in the opposite direction, you need to get the slope. Same thing here. To go from V to A, you need to get the slope. So what do I mean when I say to go from V to A? So for example, if we have a speed time graph, then we always start at V. If we are expected to find the distance, then we need to get the area under the graph. And this is what we will do in double I. If we are expected to find the acceleration, then we need to get the slope of the graph. And this is what we shall do in question I. Because this is a speed time graph, we start at V. In the next part of this video, we shall discuss distance time graphs, and we shall always start at X. So in this case, if you are required to get the V, the speed, you need to get the slope. But we will come to this when we reach it in the second part of the video. For now, we should always start at V. So since this is a speed time graph and we want to get the acceleration, we need to get the slope. During the first 10 seconds. So slope, of course, means gradient for those who are not familiar with the word slope. Another word for slope is gradient for the first 10 seconds. So we want to get the slope or gradient between these 2 points. Of course, the first point here is 0, 0. The second point is 10 and 25. So we want to calculate the gradient or the slope of these 2 points. And we use the formula y2 minus y1 over x2 minus x1. Of course, in this case, the first point is 0, 0. So we're just going to say this is x1, this is y1. And for this second point, we're going to call this x2, and this is going to be y2. Now we plug them into the formula, and we get 25 minus 0 divided by 10 minus 0. And this is going to give us 2.5. And the unit is meter per second squared. In double I, we are required to find the distance traveled by the cheetah. Of course, since this is V, a VT graph, and you want to get X, so we have to get the area. So the distance here is the area. And we need to calculate the area under the graph, this entire area. This shape is a trapezium. So the area of a trapezium is half times base 1 plus base 2 times the height. Now in this trapezium, the base 1 is this base here, the longer base. Of course, you can use whichever base for B1 and whichever base for B2. This doesn't really matter. I'm just going to use the bottom base for B1. So B1 here is 60. And then B2 is the distance between these 2 points. So the distance between 10 and 55. So this distance would be 45. I just subtracted 55 minus 10, and I got 45. And the height here is the vertical line, which is equal to 25 because of this number here. So therefore, we can now plug the values into the equation. We get half, open brackets, and then we said B1 is 60 plus B2, which is 45. And this is multiplied by 25. And this is equal to 1,312.5. And the unit would be meters. So let's check the marking scheme. 2.5 and 1,312.5 are the correct answers. The diagram shows a speed time graph for the journey of a car. Calculate the total distance traveled. Like we said before, we have A, V, and X. And we start at V because this is the graph itself. We want to get the distance, so we're moving up. So this is the area. You want to get the area of this shape. So the base here is 280. And the upper base is 220 minus 20. So this number here minus this number. And this gives us 200. And then the height is the vertical line, which is 12.5. This is the height. And then we just write the area formula down. So the area is half B1 plus B2 times H. This is equal to half multiplied by 280 plus 200 multiplied by the height, which is 12.5. We use the calculator. Of course, here this part is 480. So it's half times 480 times 12.5. And the answer is 3,000 meters. The speed time graph shows information about the journey of a tram between two stations. Calculate the distance between the two stations. So again, AVX, we start here and we want to get the distance. We're moving up, so it's area. We want to get the area of this trapezium. This distance here is 130. This is the first base. And the second base would be 100 minus 10. And this is equal to 90. And then the height here would be 20 because of this number. And we just apply the area formula. So half, you can write A equals half B1 plus B2 times H. And this is equal to half times 130 plus 90 multiplied by 20. This part here is 220. If we multiply these three numbers together, we get 2,200 meters. Next, we are required to get the average speed. You should know that the average speed equals total distance divided by total time. The total distance was already obtained in the previous question, 2,200, divided by the total time, which is 130. So 2,200 divided 130 gives us 16.92 meters per second. So 2,200 and 16.92 are the correct answers. The diagram shows information about the final 70 seconds of a car journey. Find the deceleration of the car between 60 and 70 seconds. So we go back to our model AVX. We know that if we're moving up, we get the area. If we're moving down, we get the slope. We're starting at V because this is a speed time graph. Just in case you're confused, I know that this is a speed time graph because of this label here. Now, for the deceleration is the negative of acceleration. So acceleration comes from slope or gradient. And we want this between 60 and 70. So we're going to look at the 2 points corresponding to 60 and 70. So this point here and this point. The first point has coordinates 60 and 20. The second point has coordinates 70 and 0. So in order to find the deceleration, we're going to use the formula of the slope. y2 minus y1 over x2 minus x1. So this is equal to 20 minus 0 over 60 minus 70. If you are confused as to which numbers should go where, just take the first point that you have and label x1 and y1. Take the second point that you have, label x2 and y2, and then plug these numbers into the formula, and you will get the same result. Of course, here I actually switched them, but it will give us the same result anyway. It's a good opportunity. I'm going to show you both ways. So for the first way that I did it, I did 20 minus 0 over 60 minus 70. So this is 20 over negative 10, which is negative 2. For the labels on the graph, y2 here is 0 minus y1, which is 20, over x2, which is 70, minus x1, which is 60. So I get negative 20 over 10. And again, this gives me negative 2. And this shows us that it doesn't really matter which point I label x1, y1, and which point I label x2, y2. The final answer is going to be the same in both cases. So for A, the slope is negative 2. That tells us that the acceleration is negative 2. And that tells us that the deceleration is positive 2, because the deceleration is the negative of the acceleration. So deceleration is 2 meters per second squared. In B, find the distance traveled by the car during the 70 seconds. So we are starting at V, because this is what the title of the graph is. And now we want to get X, which is the distance. So we're moving up. So we want to get the area of this graph. This is also a trapezium. So as we did in the previous problems, we're going to get the first base, which is 70. And the second base here, which is from 0 to 60. So this is 60. And then the height is 20. We can plug these numbers into the area formula. So A equals half B1 plus B2 times height. B1 is 70, B2 is 60, and the height is 20. 70 plus 60 gives us 130. So half times 130 times 20. And this gives us 1,300 meters. So 2 is correct for A, and 1,300 is correct for B. The diagram shows the speed time graph of a train journey between two stations. Find the acceleration of the train during the first 40 seconds. So again, we have our model, A, V, X. We are here. We want to go to acceleration. So we're going to get the slope. So the acceleration is the slope. We need to get 2 points to get the slope. So for the first 40 seconds, we have 0, 0 as the first point, and 40, 12 as the second point. This is x1, excuse me, this would be x2 and y2. Doesn't matter, but when you have 0, 0, normally you would want x1 and y1 to just be 0, 0. So as to make the calculation easier. So here the slope is y2 minus y1 over x2 minus x1. And this is equal to 12 minus 0 over 40 minus 0. And this is equal to 12 over 40. You can get the decimal form of this fraction. This is 0.3 meters per second squared. Next, we want to get the distance, and as we know from before, the distance here would be the area. So in order to get the area of this trapezium, I'm going to do it a bit quicker now. I'm just going to write the formula and plug in the values. A equals half B1 plus B2 multiplied by height. B1 is 300. B2 is 250 minus 40. These two numbers here get us this distance. And then 250 minus 40 is 210. And the height is 12. So 300 plus 210 is 510. We now need to multiply half times 510 times 12. And this gives us 3060 or 3060 meters. So 0.3 is the correct answer, and 3060 is correct as well. The diagram shows a speed time graph. Calculate the total distance traveled. Again, this is the same concept. Distance is area, we said. So A equals half B1 plus B2 times height. B1 is 15. B2 is 10 minus 3, which is 7. And the height is 12. 15 plus 7 is 22. So we have half times 22 times 12. And this gives us 132 meters. And this is the correct answer. Next, we move to distance time graphs. So XT graphs stands for distance time graphs. The distance time graph shows the journey of a train. Find the speed of the train between 7 and 7:30, then find the average speed for the whole journey. Now, to get the speed, we need to refer to our model again, AVX. But now we're going to start at X because it's a distance time graph. And I know this, of course, from the label of the Y-axis. So distance, and we call distance X. You can call it Z as well, but the more popular variable is X. We want to get the speed, so we're moving down from X to V. So in this case, we're going to get the slope because we're moving downwards. The slope between 7 and 7:30 is the slope between these 2 points. So we have 0, 0 here, and then we need to represent this in a way that helps us to calculate. So how much time passed here? You can either find it in hours or in minutes. Makes more sense to just find it in minutes first to make life easier for ourselves. So here, the time that elapsed is 30 minutes. So we can call this point 30 and 50. Now, in order to get the slope, we are going to write y2 minus y1 over x2 minus x1. And this is 50 minus 0 over 30 minus 0. And this gives us 5 divided by 3, which is 1.67 kilometers per minute. If we want to convert this to kilometers per hour, we just multiply by the number of minutes in an hour. So we multiply by 60 because it moves 1.67 kilometers every minute. So in 1 hour, it will move 60 times this number. So we just multiply our answer by 60, and we can rewrite it as 100 kilometers per hour. So another way to solve the same problem is to first identify this number in hours. So instead of 30, I can just write 0.5 here. And then I can replace here as well. And then I can just calculate the slope straight away. So the slope is going to be 50 minus 0 divided by 0.5 minus 0. And this gives us 100 kilometers per hour as well. So this is another way of solving the same problem. Next, we are required to find the average speed for the whole journey. So the average speed is total distance over total time. This gives us the average speed. The T capital here stands for total. So total distance over total time. The total distance here is very easily obtained. It's just the highest number in the y that the graph reaches. So this point here, this is the maximum distance traveled, which is 200. So we can just write 200 for x total. And then the time is from 7 to 9:10. If we want to write it in hours, we can write the time as 2 hours plus 10 minutes. And then we can divide this by 60 to convert it to hours. So 10 over 60 is 1 over 6. So this becomes 200 divided by 2 plus 1 over 6. And now it's in hours. We can calculate 2 plus 1 over 6. And we get a long decimal, or we get 13 over 6 as a fraction. So 200 divided by 13 over 6. This is the same as 200 times 6 over 13. Keep, change, flip. And we can just find this as a final answer. 200 times 6 divided 13 is 1,200 over 13, which is roughly 92 kilometers per hour. So 100 is correct. And they wanted 92.3, so 3 significant figures. This is my mistake. This calculation on the calculator actually gets you 92.3 kilometers per hour. So the whole problem is correct. It's just an approximation issue where you should just make sure to write the exact answer, or at least, at the very least, to 3 significant figures. The diagram shows the distance time graph for the first 65 minutes of a bicycle journey. There are 4 different parts to the journey labeled A, B, C, D. Write down the part of the journey with the fastest speed. So this is a distance time graph. And to get the speed, we are moving down, so we're getting the slope. So instead of fastest speed here, I can actually write highest or biggest slope. So which part of the graph has the greatest slope? Slope has to do with steepness. So you should think of how hard is it to ride the bicycle in these sections. In C, for example, this is a horizontal road, so it's relatively easy. In D, you're moving uphill, so it's harder. In B, you are moving uphill, but it's much steeper, so much harder to ride the bicycle. And in A, it's almost impossible. It's very, very high, very, very steep. So A has the greatest slope. So therefore, the answer is A. After the first 65 minutes of the bicycle, after the first 65 minutes, the bicycle travels at a constant speed of 20 kilometers per hour for 15 minutes. Draw this part of the journey on the diagram. So starting 65, we want to represent the bicycle traveling at a speed of 20 kilometers per hour for 15 minutes. How would we be able to do that? You need to think of the distance traveled. So the speed here is 20 kilometers per hour, and the time is 15 minutes. And in motion problems videos, you learned that we have a triangle like this. We have X, we have V, and we have T. So in order to get X, you just need to multiply V by T. But of course, you have to make sure of the units. So this is per hour and this is minutes. So it would be good to convert the time from minutes to hours. So 15 divided by 60 gives us 0.25 hours. Now we can get the distance as 20, which is the speed, multiplied by 0.25, which is the time. And this gives us 5 kilometers. So starting 65, in the next 15 minutes, it travels a distance of 5 kilometers. How do we make use of this? In this case, we start here at this point. This point is 65 for the X and 23 for the Y. For the next 15 minutes, so we add here 15, it travels 5 kilometers, so we add 5 to the distance. So the ending point is going to be 65 plus 15, which is 80, and 23 plus 5, which is 28. So therefore, we finish the graph at 80 and 28. 80 and 28 is this point right there. And we join these two parts, these 2 points, I mean, together. And this will be satisfactory as a final answer. So A is correct. And then for B, you want to join 65 to 23 with, you want to join 65 and 23 with the point 80 and 28 as we specified. And this would give you the correct line. For the new problem here, we are told the travel graph shows a student's journey. Explain what is happening between 1420 and 1440. So 1420 is this point here, and 1440 is this point here. And since this is a distance time graph, we should remember AVX. And to get the speed, we now need to get the slope or the gradient. What do we know about horizontal lines? Horizontal lines have 0 slope. The gradient or the slope of a horizontal line is 0. And therefore, since slope is speed, we know that the speed here is 0 as well. So if the speed is 0, this means that it is not moving or at rest or stationary. You can write any of these. They all mean the same thing. For B, we are told the student, complete the statement, the student is traveling fastest between the times what and what. So you should look for the highest slope. And the highest slope, of course, exists between this point and this point. So we can write between 13, and we need to get the value, of course, of the point we have. So from 13 to 14, this tells us that here, this is 1330. It's right in the middle. So it's 13.5 or like 1 p.m. and 1:30 p.m. And since this is 0, 0, and this is 30, we should know that this would be 10 or 1310. And this here would be 1320. So between 13 and 1320 is the section we're looking for. We can write 1300 and 1320. And how do we know this? How do you know that this is when it's traveling fastest? It's because gradient is greatest or steepest, gradient or slope. These all mean the same thing. So you can write the slope is the greatest or the gradient is the steepest or whatever. These would all be correct. And Both answers seem to be correct. Student is stationary or at rest in A, and in B between 1300 and 1320 because the gradient is the steepest. So this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.